We'll be solving a lot of questions on energetics and thermodynamics. I hope you are with your writing materials so you can jot down these questions I'll be giving to you, the explanations, the solutions. However, what I urge you do, if I believe you've at least in one way or the other been taught energetics and thermodynamics, you have a little bit of knowledge on energetics and thermodynamics. So if I give you a question, I want you to write down the question, pause, try to answer, try to solve, and see if your answer is in the options given to you. Then you play the video again so you see the correction or the solution for the question and see if you're correct or wrong. So once you're wrong, you learn from your mistake. So look at the first question, number one. Number one. The study of the flow of energy is called option A. Option A, we have inorganic chemistry. Option B, we have analytical chemistry. Option C, we have organic chemistry. Option D, we have thermodynamics. Now, this is a simple question. So I'll urge you to put down this question. This is our first question because we have a lot of questions to actually cover in this series. So the study of the flow of energy in and out of a system is not inorganic chemistry, is not analytical chemistry, is not organic chemistry. This is a straightforward question that we should know that the answer is option D, which is thermodynamics. So in a nutshell, thermodynamics is actually the study of the flow of energy in and out of a system. Now, the next question we are going to look at now, number two, the parts of the universe under investigation or observation is called option A, system. Option B, option B, surrounding. Option C, boundary. Option D, none of the above. Now, if they give you something like this in the exam and you're asked which part of the universe is under investigation or observation, that's a simple thing. One thing you should know. Now, there are three terms in thermodynamics that we should understand. One is system. The other is surrounding. Then the other is boundary. Now, any part of the universe that is under investigation or observation is called system. So, if this part of the universe is under investigation, there's a reaction occurring in this part of the universe, and I'm observing it, I'm investigating it, that part of the universe where I'm observing and investigating is called system. It's called system. Are we there? Now, around the system, is the surrounding. So surrounding is the part of the universe that is not under investigation. So the part of the universe that is not under investigation, the part of the universe that is not under investigation is called surrounding. However, the imaginary line separating the system from the surrounding is called boundary. The imaginary line separating the system from the surrounding is called boundary. So we can actually answer this question. The part of the universe under investigation or observation is not called surrounding. Surrounding is the part that is not under investigation. It's not called boundary. Boundary is the imaginary line between the system and the surrounding. Now, what's not system? System is the part of the universe that is what? That is under investigation. Now, one thing you should know is that system plus surrounding will give us universe. System plus surrounding will give us what? Universe. So the answer is not surrounding, is not none of the above, is not boundary. The answer is system. So we've answered the first two questions. I hope these are on your notes and the answers are also marked on your notes, and I hope it is very, very clear and simple. Now, I can clean now. All right. So, like I said, we have a lot of questions to solve or answer today. Now, number 3 question is a system that exchange both mass and heat with its surrounding is called option A, closed system. Option B, open system. Option C, isolated system. Option D, isothermal system. Now, first of all, we'll understand the concept of a system. So I'll urge you to write this third question on your notes and try to answer. Then wait for the solution. So let me explain. We've explained the concept of system, surrounding, and boundary, right? Yes, like I said before, system is the part of the universe under investigation, right? Now, surrounding is the part of the universe that is not under investigation. Then the imaginary line between the system and surrounding is what we call boundary. However, we have 3 types of system in thermodynamics. Generally, we have a closed system, we have open system, we have isolated system. So in this case, this is actually off this question. Isothermal system is out because we generally have 3 major types of system: the closed, the open, and what? The isolated system. Now, for open system exchange mass and heat with its surrounding. Closed system exchange mass only with the surrounding. Sorry, mistake here. Exchange heat with the surrounding. Mass is not exchanged. So the open system will allow the flow of mass and heat between the system and the surrounding. The closed system will allow only the flow of heat. Mass will not flow. Now, isolated system. The isolated system neither exchange heat nor mass with its surrounding. Okay, this will allow the flow of mass and heat between the system and the surrounding. Now, closed system will only allow the flow of heat between the system and the surrounding. Mass not exchange. Isolated system will not allow the flow of mass and heat with the surrounding. Now, I'm going to explain with three different diagrams. Now, if this is a pot and this pot contain water, now, and the water here is hot. Now, after some time, there will be exchange of heat such that the heat, the hotness will go out, then cold will go in. There'll be exchange of what? Of heat until you get to a time where we reach a equilibrium. That means you can also see that there's exchange of what? Of heat. So if you come back after some time, this system will become cold due to exchange or flow of what? Of heat outward. However, you also admit that this water here evaporates. So we are going to lose mass of water. There'll be exchange of mass. We are losing mass. And there'll be exchange of what? Heat. So this is an open system. Now the open system will lose heat and we exchange heat and we exchange mass, right? Yes, we are going to lose mass of water. Now, over some time, you discover that the quantity of water will reduce, loss of mass. And over some time, this hot pot will become cold, loss of heat. So we call this open system. In an open system, there's both flow of heat and mass. But watch, for closed system. Now, open system is like what? An open pot with water, with hot water. Now, closed system is like hot water in a closed pot. Now, this is hot. After some time, this hot water will become cold, loss of heat, exchange of heat, loss of heat. However, water will also try to escape, loss of mass. But however, the water trying to escape will hit the surface of this container, this cover, and return back. So there is no loss of mass. So an example of a closed system is a pot with hot water, but the pot is closed. I'm going to call this closed system. Now, for isolated system, there is neither loss of heat nor mass. There is neither exchange of heat and mass with its surroundings. So no flow of heat, no flow of mass. An example is the thermoflux. The thermoflux. The thermoflux. Now, the thermoflux, like the normal baby flax, now we contain hot water. Hot water. Come 3 days later, the water will still be hot because it minimizes what? Flow of heat. And also because it is closed, there will be no loss of mass. There will be no what? Loss of mass. So I've been able to explain the concept of open system, closed system, and isolated system. So let's answer this question. A system that exchange both mass and heat with its surrounding. This one will exchange both mass and heat. This one will exchange just heat only, no mass. This one will not exchange heat and will not exchange mass. So the answer is a an open system. An open system will exchange both mass and heat. So I hope I've been able to explain that. That is quite easy. So if you understand this, I think I have a similar question here. I have a similar question here. Number 4. A system in which only flow of heat is possible, but flow of mass is impossible. Option A, open system. Option B, isolated system. Option D, option C, adiabatic system. Option D, we have what we call closed system. So if I were you, if you see this kind of question in exam, you just smile and laugh because I've been able to explain the 3 major types of system: the open system, the closed system, and what we call the isolated system that we have here. Let me remove this. Isolated system. This one will allow flow of heat and mass. This one will allow flow of heat but no flow of mass. This one will allow what? Does not allow flow of heat and flow of mass. So in the question, a system in which only flow of heat is possible but flow of mass is impossible is not open system, is not isolated system. The answer is what we call closed system. Closed system. Are we there? So we're able to answer 4 questions now. I hope it is so easy. This aspect of chemistry is so easy. Just follow me. Just follow my lead. You discover that chemistry is so simple. So I can clean. If you've not written the question or this thing here, you can just pause and write. So if you are feeling this series, I don't see why you are not subscribing and turning on the notification button. It's devilish. Try to encourage me by what? Subscribing, turning on notification button. You don't pay for it. Number 5. Which of the following is a state function? Which of the following is a state function? Option A, we have entropy. Option B, we have free energy. Option C, we have enthalpy. Option D, we have work. However, let me attach the symbol used to represent these guys. Entropy is represented with X. Free energy is represented with letter G. Enthalpy is represented with the letter H. Work, we can just say W. Now, the question now is, what is state function? State function are properties of a system that actually depends on the final and initial state of the system. Any parameter of a system that depends on the initial and final state of the system is called a state function. Now, state function does not actually depend on the paths followed, but rather initial and final what? State of the system. What is a path function? A path function, with what I have here, is a parameter of a system that does not follow or depend on the initial or final state of the system. However, the path, P-A-T-H, the path followed by the system. Now, how do we know the series of examples, a lot of examples of state function I'll be giving to you? Now, entropy is a state function. Free energy is a state function. Enthalpy is a state function. Work is a path function. Work does not depend on the final and initial state of the system. It is actually path dependent. Path dependent, depend on the path follow. Now, I'm going to show you how I usually know majority of all the state function. I use a mnemonics. And what is the mnemonics? The mnemonics is when I am under pressure and feeling dense, all I do is to watch TV and get some hugs. So I'm going to highlight the state function here. This is a state function. This is a state function. These are state function. These are state function. So, what are we trying to say now? Pressure is a state function. Density is a state function. TV will give us temperature and volume. Temperature and volume are state function. The next, hugs. I've highlighted this, that H will stand for enthalpy. U is internal energy. Take notes. What again? G is Gibbs energy. Gibbs energy is also called free energy. X is entropy. So with this, we can actually know a lot of properties of a system that are what? State function. Pressure, density, temperature, volume, enthalpy, internal energy, Gibbs energy, and entropy. So if I come here now, which of the following is a state function? Entropy is a state function. We can have delta what? X. Now, free energy is a state function. We can have delta G, where we have what? Final and initial. Now, enthalpy is a what? State function. We can have delta H. Now, work is not a state function. Work is path dependent, so is a path function. Work is not a state function.